Well, hello. In this session, we are going to talk about spark plugs. Something that have been around for 100 plus years, understood by some, not so well understood by others. As the evolution of technology has moved forward, especially in the automotive venue, we've learned that spark plugs are just not as apparent as they once were. They're buried under valve covers, with coil and plug and so on. But they're a real thing. They can give you trouble. So if we're working on anything from ag equipment to small engines to the latest in vehicle technology, we'll still need to know the basics about spark plugs. So that is going to be what we're covering today, is the basics of spark plugs. Okay, now as we go through the different configuration of spark plugs, you can see here that we have deep reach spark plugs. We have shallow, like you'd find on the small engines. But take special note that these designs actually have a metal gasket. So the tightening of these are slightly different. The other style we have are going to be a tapered seat configuration. So here we have the spark plug that's threaded in and sealed up against the seat itself. Now let's talk about heat range, because that's really the discussion here that's most important. So we have different lengths. You can see the protrusion of the porcelain. So that's one portion of it, how far that protrudes into the cylinder. That's designed by the manufacturer, needing to know where exactly to put the electrode for optimum performance. And then there's some other details that we'll be covering here shortly. You see these are the old style 18 millimeter versus our 14 millimeter. And our 18 millimeter spark plug here is going to be used more often in old applications. So a lot of automotive truck application had this, and it's still commonly, I wouldn't say commonly used today, but you find it more readily in agricultural applications. And you're probably taking note of something odd here. And these are a neat piece that I've been utilizing in a lot of our farm tractors here. And that is simply a adapter that goes from 14 millimeter or 18 millimeter down to 14 millimeter. And where this really works out is allows me endless amount of different heat ranges that I can install versus the situation where I'm limited on what I can put in. So here is an example. I just have a 14 millimeter plug, and I can choose literally infinite number of heat ranges. Try to find in the old fashioned 18 millimeters, many different heat ranges, very limited. So if you're doing some modification, everything from tractor pulling to antiques, again, this is kind of a neat investment. I've been using these. I buy them by the brick from a company out over in Michigan, and so I have them in literally all my equipment around here, and I put them in a lot of collector pieces. So I wanted to pass that on. Okay, let's get talking about the heat range itself. So within the spark plug, you can see where the depth of the porcelain is, how that's sealed, where this is in, and there's a lot of other configurations we have to consider here. What the performance of the plug itself is. We need to look at how it gets rid of the heat, where it's put in from a performance standpoint, and the heat transfer, how is that going to impact the spark plug. Well, you can see here we have the three different versions. We have one that is intended as a high heat range. So the seating of the porcelain goes very deep in. So this is going to get extremely hot. And that's what the goal is. We want it hot. That's going to be a spark plug that works nice in the high heat range. The next one is going to be our classic medium. And then you're going to have a cold plug. And them are the ones that often get you in trouble. So just grabbing one out of your parts cabinet or parts store, hey, I need one that threads in like this. Well, there's more to the spark plug than you're observing from the outside. So that heat range number that you're looking at, that part number, is absolutely critical. So make sure you actually look that over and get the right spark plug. Okay, so here's what happens. If we have a hot plug, it's going to be resistant to carbon fouling, but prone to pre-ignition, electrode burning, rapid wear, and can deteriorate the engine, sometimes very rapidly. So the choice is critical. Now, on some of the older applications, all fairness, you will learn if you've done modifications. You put a supercharger, you put a turbo on there, you got nitrous, you change the compression ratio. Now you have to consider what you're going to do with the spark plug heat range. So that is going to be a variable that you'll have to contend with. Now you've become the engineer once you've done that. So having a good understanding of the spark plug heat range is going to be critical. So let's talk about this temperature. When we get up here, this is in centigrade here. So if we get above around 1100 degrees centigrade, we typically now are in auto ignition. Basically think i.e. diesel. You got so much heat that that hot spot is simply going to light everything off. And then you got your safe range, where you're getting right up there. And that's going to be, the idea behind that is that if you're going to be running a little hotter, you're in extremely cold conditions, or you have a vehicle that is frequently started but never warmed up, you may have to move your heat range of the spark plug up into that point where you can still get the plug clean enough. But if you're going to be using it under very heavy load conditions, you're going to be in that narrow orange band here that could get you in trouble. Then you have your normal operating range, and you can see we're just a little above 400 to around 900 degrees C, and that range is what most engines are configured around. So we can go way back and up, very, very modern. It's a function more of the fuel than it is fuel/compression versus the heat of the engine. So them are all going to be the factors building into this. Okay, so now we're going to talk about something else that's kind of interesting, and that is going to be if it has a resistor or not. In other words, an R-type or RFI suppression spark plug. And what they basically do is, you can see from the picture here, they put a resistor in. And what I'll give you a little piece of information that I've learned over the years. This configuration here that I was talking about using in a tractor or some other antique applications, if it runs an old style magneto and it uses this resistor, you will have a significant amount of hard start or no start condition with it. The magneto discharges at such a rate that that high resistance resistor that's located in there will actually give you quite a problem. It will not allow you to get the energy across there. So if you look at here, they're stating this is a 200 megohm resistor. That generates normally versus a non-resistor style spark plug. So think about a coil buildup. Your coil is going to build up, get to saturation, and ionize across that gap. So in the case of a resistor, you in a sense have two dynamics that get over, let alone the rotor index issue. So you got a whole series of things to jump and talk about. So when we go into scopes in a later episode here, we'll get into that great detail. But right now, let's think about it. The spark plug itself, so if it's going to have suppression resistor in there, that's going to eliminate radio noise, interference with electronics, but is going to have to take a little bit more energy to go through. Our coils are usually 4 to 10x more than we need for the ignition itself. So it isn't that critical, but you take an old magneto. So remember, if you're using this technique with this adapter and putting a modern spark plug in, may not get the performance you had hoped on if it's involved with a magneto style. A number of things here that we want to talk about spark plugs, and that is really, really critical. So an example here, spark plug leakage, distortion load, torque, internal resistance, combustion seal, and then its maximum temperature that it can operate within. Some of them are all criteria that are established by the manufacturer. And it reminds me of something that I always find kind of interesting here is I have a variety of different manufacturers, and it's kind of like cars, motorcycles, snowmobiles, you name it, or sports teams. Everybody's got their favorite, and there's a reason theirs is the best and other ones are the worst. My experience, I probably have changed out 10,000 spark plugs in my many years, and I cannot tell you that one is that much better than the other. You find some quality issues, and I have to look at quality as being one of the biggest factors, is failure of the plug if it gets stressed. So that's something I've seen over the years, but usually if it's getting stressed, there's something going on. Either improper installation has been one of the more common ones that I've seen. The one that I always kind of disliked, that I knew it was really a quality issue, is when the porcelain would actually push out of the metal formed section of the spark plug itself. So I've seen that a number of times, and that is just a poor quality spark plug. Okay, let's talk about combustion itself and how it affects. So things that you're making a decision on changing out the spark plug. As you can see in this one here is out of a small engine. Looks pretty normal, a little bit on the darker side. Needed changing because we want to start them when they're cold. That's one of the keys is get a new spark plug in there. Here's one off of agricultural application where the operator didn't know that the choke needs to be pushed in. I can tell you a little story on that one. So it had a very powerful coil. It was able to withstand quite a run, but reality is when you're just literally pouring liquid fuel in there from a choke being left on, eventually it's going to meet its expectation of where it can go. So this was a kind of a good example of that. So let's talk about here. A normal plug is going to have a kind of a small amount of whiteness on there, just kind of a tan color. You might have some additives. Everybody's big on the miracle juice, especially if there's a problem. So they find something at the parts store and they put it in there, and a lot of times them additives can build up on the spark plug itself, not necessarily causing any problem or may cause a lot of problems. But in this case here, we're just talking about light additive buildup. No sign of leakage. So if you're looking at the spark plug itself, you're not seeing any combustion gases that are leaking by either where the crimping goes down here for the porcelain, or of course if it's not sealed tightly with the gasket or the tapered fit. We're looking for the color again of the porcelain, and then uneven wear on the electrode itself. So that electrode, and that is something that is not quite as critical, especially as you get into modern spark plugs with the exotic metals that you have. Here's a Bosch Platinum. You don't see them things wore out. They go 150,000 miles, and it seems like there's virtually no problem with them unless you have some type of other related. But under normal use, not kind of a problem that I've seen. Okay, well, here's one with a little bit of a reddish color. That is simply unleaded fuel. We have, and that's been around for a long time, but the reason I brought up lead or unleaded is we still have aviation fuel, we have other special lead additives that are out there, so they are still used in many different configurations. We have sulfur will give it kind of a yellowish color. Let's not forget about it, I don't have it listed here, but additives within coolant. If you've got a small head gasket leak or a leak on the intake manifold, that can change that. I've seen purplish colors, I have seen reddish colors, and I've seen greenish colors that are caused by typically antifreeze getting in through and being burned in the combustion chamber. Usually a small amount, but it's enough to change the color from the dye that's put in the antifreeze itself. Okay, carbon fouling. Here's an example we were talking about with carbon fouling. Probably one of the more common ones you're going to see is carbon fouling. Something's gone wrong. The ignition system's failed. The engine's gone into overfueling. So this could be everything from a little Briggs & Stratton all the way up to a direct injection gasoline engine. They fail. And when they fail, often it's going to show up on a spark plug. You need to be able to read that spark plug. That's part of the troubleshooting, the diagnostics that's needed, is to make sure that you, as a skilled technician, can read the spark plug and determine, okay, that's carbon fouled because it's wet. It's too cold to spark plug. The engine's run into a excessive idling time, things of that nature. So we have to. That's where you start making that decision. Do I fix a problem? Do I change the heat range in there? You know, so is it overfueling? It got a bad pressure regulator on it? Is it an older style carbureted vehicle, choke issue, or is it simply the ignition system is putting out such a low amount of energy that it's fouling the plug out simply because it can't generate enough sparks, so we have an excessive amount of misfire. Detonation, that is the death of a lot of components. So this detonation is simply low octane. I have a supercharged vehicle, so I'm very aware of octane considerations. Over advancing on the old mechanical timing, but let's not say it. I've done a lot. Some of you had experience with this, where you do programming on a late model one, changing and altering timing and fuel calculations. You can quickly have this. So reading the spark plugs are kind of the ultimate. With NOx sensors that are on cars now, really going on 30 plus years, we haven't talked about detonation much because we don't hear it. Many manufacturers will run the vehicle right at that jagged edge of detonation, but not enough to harm the engine. That's where maximum fuel economy and performance is found. So it's always that finite condition. If you're driven vehicles with manual transmissions, again, lugging the engine, so too high a gear, too heavy of a throttle opening at too low a speed can cause this simply because they can't back the timing off far enough. Okay, fuel fouling. Now, we kind of talked about that earlier. So this is where you actually have so much fuel going in that spark plug is, think about it, is shorted out. It's incapable anymore of actually firing. So it's not even an option for you. So in that particular case there, that is going to be typically, it's going to be your magic P0300, whatever number, and you might pull a spark plug out and you find out, okay, it's overfueled, it's fuel fouled. What would cause it to fuel foul? Well, my experience, and I am on some fairly late model vehicles, typical fuel injector stuck open for whatever reason, and I've run into them both mechanically stuck open and electrically stuck open, where most was involved and simply shorted it out, and it's got on the ground side of it, one injector is simply hung open and is overfueling. Two, as I said, conventional, just bad injectors. Glazing. Now, this is caused typically by too hot of application, where you're getting right on that jagged edge of overheating. I've also, word to the wise, whenever you change spark plugs, this is an old piece of information from yesteryear, but it's as true today as it was 30, 50 years ago. What we have is, when you put new spark plugs in, take it for a modest drive, and the little pores in the electrode need to basically get filled up with combustion carbon to seal them off. And if you go out and you put new plugs in there and immediately put it to the floor, put very high cylinder load, excessive fuel, you'll actually put on, in some applications, some situations, you'll actually have a conductive buildup that will happen within the first mile of driving. So remember that when you put plugs in, take it for a mild, easy drive for the first mile or two, and then you can run the life out of it after that. But try to make it that first little bit. Lead fouling. Again, we were talking about lead now is something that hasn't been around now, going on for basically 50 years. But there's additives, lead additives guys put in. There's aviation fuel. So there is these where we're going to get involved with lead in certain applications. Also, remember, you could also have PCV related issues where you have certain types of oil have a high content of ash in it, and that ash can get on there and give you the similar illusion of what you would have with the lead fouling. Oil fouling. This is where you basically have an engine where it has poor oil control. Valve guides, you might have an intake manifold, depending on how it's configured, where it's sucking oil from the valley. You could have a PCV related issue. You could have an engine. Well, I've seen this on a couple occasions. If 4 quarts are good, 8 quarts are better. Well, I have no idea, but they overfilled it. The crank is literally flopping around in oil, and it just simply oil fouls out all the spark plugs. I remember some years ago, I was teaching a class, and the student was had brought a vehicle in, and it was barely running, and they pulled the plugs out, and the fix they thought was going to be putting new plugs in. Well, it needed new plugs, but let's get the other 4 quarts of oil that shouldn't be in there. That was the root cause. This was just the symptom. So oil fouling. So if you do a lot of engine work, you know exactly what I'm talking about here. Okay, pre-ignition. So that's going to be a situation of the ignition fired too soon. So we'd have ignition timing, the programming, or simply physically the distributor in the wrong position. It still happens today, even if you get outside of the programming. Things slip. Guys put engines together wrong. They mismatch parts. These kind of things happen. So you can have an engine, even on a modern digital controlled, where it's actually got too much advance. Just plain worn out. You don't see that as much. We're talking about plug configurations here. Not quite as much as it once was with plugs just plain old wore out. But plugs still plain old wear out. So when you're going in, thing is, we think now, used to think in terms of 5,000 to 10,000 miles for spark plug changes. Now we look at 100 to 150,000 miles. And if anybody's been around some of the magic Fords where you can't get the plug out of them, that is something. So one of the reasons we change spark plugs isn't only because the plugs wore out, is that if you ever want to get it out, you better get it out before the carbon ring builds up too much on the very base of the plug itself, and you break it off in the hole, and there's nothing worse in the world than that happening. Okay, a couple different spark plug configurations out there. We started talking about that. So you have your conventional plug, and then we talked about the Bosch, and there's iridium, and you just name it. There is so many different configurations. But normally, if it's going to have any kind of hard, precious metal in it, it's not going to have a flat deck on it. Like this, it's going to have a tapered point. So you can read the brochures and figure out exactly what you have. I've seen them, they work. I mean, I can't find a reason not to. Typically, it's a dollar and cent situation. But every misfire you prevent, there's two things. One keeps more money in your wallet and keeps the environment clean. So think about it from that perspective. Here, here's a little AC Delco, their design. We have some split fire style. So these are typically ones that will work a little better if you're in an environment that has a more of a fouling condition or a big variable. Some of these higher end plugs really work excellent in that kind of situation. In this next section, we're going to get into a lot more of the detail of the spark plug and what it lives in. So let's talk about this here. Things that get to the spark plug. So we can have valve guide problems. We talked about cooling system leakage. Things of that nature are going to get at that spark plug. And that's the idea. What you're going to be reading when you look at the plug is you're going to be reading what is going on inside a combustion chamber. So having that depth of knowledge is absolutely critical. And even just the logic of getting in and using that as a diagnostic tool. So don't think about spark plugs just simply as something you're going to change. Think about them as part of the diagnostic strategy. If you've ever been involved with motorsport racing, from drag racing to super bikes, the snowmobiles, you name it, reading spark plugs is what the pros do. And there's folks out there that are 100 times better than me when it comes to reading spark plugs in their particular application. I'm looking at it from more of a holistic overall perspective, but when you get into a specific industry, you're going to find that depth of knowledge is absolutely critical. If you are in a specialized industry, make sure you go out and find that expert. If it's on YouTube or at the racetrack, whatever it is, learn that. You can learn so much in that regard. So that's something to study, but that's where we're getting into the real specialized application. Valve guide problems. It's still a thing today. The engines last a long time, but valve seals go out, guides wear out, and oil gets in there. So it doesn't have to be an old antique. We still have a problem today as much as we had yesteryear. It just, the problems seem to come on much higher mileage. You know, we used to have problems at 50,000, now we have them at 200,000. But it's still the same problem. Okay, let's get talking about normal combustion. In a normal combustion environment, we're going to have the spark plug ignite, and then we're going to have a flame front propagated. In other words, that pressure, this is happening within just milliseconds. So we have the spark plug ignites, the pressure wave goes out, that's the forest fire thing, grass fire, the best way to think. Grass fire is it's rapidly burning across all the fuel molecules, and then we get all the way out and it's pushing that piston down. So the timing of that piston, when the ignition fires, the fuel type, temperature, all that, to get the maximum cylinder pressure based on the throw of the crank. Usually the old number I've always worked with, 18 to 23 degrees after top dead center, just like pushing out on a bicycle pedal, is the maximum leverage. The stroke of the engine is going to be the biggest factor on that. The bore is going to be one, and the fuel type, them are all the variables. But that's a discussion for another class. Okay, now let's get into it in detonation. So we're going to have a situation here where spark takes place, so it looks like normal combustion. But now what happens is we have another propagation point. Let's go back to this here. So a normal event, the cylinder pressure starts to build up. A secondary combustion occurs because there's some carbon in there. We have extremely poor quality fuel, and we have two flame fronts that are coming at each other at sonic speed. And what they're doing is when they hit, that vibration, so first off, they burn too quick, so you're getting full pressure before that piston is capable of getting into the right angle for the stroke of the crank, and that cylinder pressure is really, really, really hard on the top of the piston. And all the parts, connected rod, bearings. I've seen bearings that have been deformed from this. So that is something we all need to be very aware of. We don't hear it like we once did, because if we have this occurring, if it is an engine designed with a knock sensor, that knock sensor is going to retard the timing. So that's strictly a fuel economy issue. I've seen situations where somebody put the wrong cylinder head on, a junkyard at the engine, and it had too much compression, and that engine just got terrible fuel economy because it was always in the retarded ignition condition, but it never set a code. That was a little bit of a brain twister, but that was some years ago. So here's what actually happens. When you have excessive pressure, you'll see it deformed or damaged. Often a big chunk of a piston will be down in the oil pan. So keep this in mind. So now we're back to, this is kind of the root. So the spark plug heat range, loaded it's going to be under, all of that. If we have detonation caused by excessive carbon, too hot a spark plug, timing on, well, that would be pre-ignition, but any of these, this is ultimately what is one of the bigger factors. It will crack the piston, it will damage the ringland area, put excessive, so you'll damage the engine. So even an innocent mistake by putting in the wrong heat range spark plugs can have this kind of catastrophic long range effect. So now let's talk about pre-ignition. So what's going to happen here with pre-ignition is simply a piece of carbon, and it works just like a diesel. What's happening is that fuel is being ignited long before the spark plug goes off. So now we got them two opposing flame fronts hitting. One, in this case, it started before the ignition. So that was going to be pre-ignition, the term pre-ignition. And the other one was detonation. That's because we had ignition, and then the cylinder pressure built up, and it caused a secondary front. What you'll see is still the same damaged piston, the same rattling noise, but these are two distinct reasons. This is the old classic of decarboning the engine. That's 9 out of 10 times. but I've run into little screws and stuff to get into the engine, get on top of the plug, or on top of the piston, and will cause the situation where you have a hot spot generated by a foreign object embedded in the top of the piston. Again, same crash and the effects of on the piston itself. Okay, let's move on to the next thing. Let's think about installing. Torque wrench is critical. If you're not installing with torque wrench, you are playing with fire. You can get by with the old-fashioned cast iron heads. Yeah, I guess we could all say you can get by with it. But the reality is, try to use a torque wrench when it's all possible, because professionals use torque wrenches, amateurs don't. We'll leave it at that. Let's talk about spark plug sockets themselves. So I just grabbed a variety of different ones here. Here's an unusual one. You see it in once in a while applications, i.e. Ford and a few motorsports and so on application. And that's our 9/16 spark plug socket. And the most common of all is going to be the 5/8 spark plug socket. And then a little less common, but has been around for a little longer than forever, is going to be the 13/16 socket. There is some other odd ones out there that I did not include because they're getting into some of the antique. And then some of this odd size, and that isn't antique but fairly new. And this would be, example was an 18 millimeter. And as you can observe, this is not a spark plug socket. So I have the 3 sizes, but I don't have the 4. So when I'm getting involved with that condition here, where I'm going to use this 18 millimeter, I can't put it in like that, heaven forbid. So let's look at this here. Let's grab one of these. I put it in. The plug is nice and solid in there. That's because there is a boot. This is what the difference between a spark plug socket is. Okay, the difference between a spark plug socket and a conventional socket, one primary thing is it's got a protector that's going to grab the porcelain. It's going to be in here, and then you're not going to be able to twist the spark plug and let it get locked up against the inside of the socket. And in this case here, I guess we should get the right size ones. But that could twist and it'll crack the porcelain. That's the B team that's using a conventional socket. So you're going to say, hey, why do you have a regular socket out there? Because I don't have the right size. So option B is this simple. A little extra work. Just cut up spark plug boot. Down. Put it in. It's going to work the same way. Take it off. Remember to pull that out. Sometimes these aren't going to be the easiest spot to get to. But critical so you don't break the spark plug itself. And this is typically what happens is you have a break in the porcelain. It causes a misfire. And this is, look at, I did the work myself. We all seen this from lay people that do some of their own tune-up work. And probably should have left alone because it worked a lot better than after they fixed it. And that's the amateur kind of things that happen. So be a pro and make sure that you have the right tools so we don't have that kind of condition. And last but not least, let's talk about spark plug gapping tools. I've got a whole variety of them. But the key to this thing here is making sure you gap it correctly. This is an old school one, been around for a little longer than forever in my world. So I'm going to set that one at 35 thousandths of an inch. I can take this and I can expand it out. I know a lot of people have different opinions on tapping it back or taking a tool. But make sure that even though you got all these spark plugs from the parts store, make sure you verify the gap on them. There's this style here because some fool at the parts store may have dropped it right on the ground. So you can see here we're right at the 35 thousandths. Many different configurations here. Another tool that can be used for measuring. I guess we'd say a little one you keep in your pocket. And you got a little version of it. So there's quite a few different types to go around. And before we end this, let's talk about one thing here. Science. Spark plugs are well defined here. This is a Bosch manual. So if you want to learn about detailed information, how this stuff works, this would be a good example of a Bosch handbook to go through and get more in-depth understanding. If you're making hard decisions in a race application, would be one of the ones that I guess I've learned the most, is being around a variety of different race application and industrial applications. Then you can learn, and you're experimenting, but utilizing the right tools out there to get that information. I want to thank you very much for your time. I hope this was beneficial. I will be going to the next level list in future ones, where we're going to get into waveforms and scopes and understanding instrumentation portion of how to test this. So thank you for your time, and have the most wonderful day.